So we have seen that data members and member functions of a class can be static, but objects can also be static. Just like variables, objects, when they are declared as static, they have the scope till the lifetime of a program. Okay, so if you make any object static, then it will exist till your program is existing. Okay, so how can we create any static object? By writing the keyword static, then the name of the class, and then the object name. Okay, so here is example also. Test is the name of the class and T is a non-static object. While if we proceed test with keyword static, then it will become a static object. Okay, so now let us try to understand these static objects in detail using some programming exercise. So here let us create a class. Suppose the name of the class is sample, and inside this class let us have a constructor sample. Inside this constructor let us print something, cout constructor called. Okay, and let us also have a destructor sample cout destructor called. Okay, so this is the class, and let us have the main function here. Inside the main, let's print some statement. Main, inside main, let us print it. Or we can say main starts. Okay, then create an object S of class sample and then print cout main terminates. Here we have not created any static object yet. Okay. Let us try to run this only and see what it is doing. So main will start, then S object will be created, so constructor will be called, and then main terminates, and destructor, after terminating the main, the destructor will be called. Okay, and now let us create a function here void f, and inside f create some object s1. Okay, and here we will call function f. Now let us run this. So what is happening here? Main starts, then sample s will be created, so its constructor will be called. Okay, then we are calling function f, so s1 will be created, therefore this constructor called statement is executed. Then when we get out of this function f, then what will happen? This object s1 will get out of scope. This object has lifetime only inside this block, only inside this function. Okay, so when this function will end, this object will also be destroyed. That is why it is printing destructor called. So S1 is being destroyed. Okay, and then we return to the main function, and the statement is executed. Main terminates, and before terminating the main, the destructor function is called. Okay, and destructor function destroys the object S. Okay, so this is happening. Now, instead of using normal object, let us make it static and see what happens now. Now what is going on? Main starts, then S will be created, constructor called, then F will be called, so S1 will be created. Now S1 is a static object. Okay, so constructor called because S1 is created, and then this function terminates. Okay, but now what has happened? The function has terminated, but the destructor is not being called. Why is the destructor not being called? Because this is a static object, and as we saw in the lecture slides, a static object has lifetime throughout the program. Okay, so although its scope has ended here, it is accessible only inside this block, but its lifetime is throughout this program. So it will end, it will be destroyed only when the program ends. Okay, so therefore when we return from this function, this statement will be executed, and then before terminating the main, actually the destructor will be called. Okay, so S1 and S, they will be destroyed. Okay, so let us modify this program to include an object ID so that we can know which object is created and which object is destroyed when. Okay, so we create a variable ID. Let us create it in the private section. Int ID and static int count, which will keep track of the count of objects as we did in an earlier program. Okay, so here we are printing constructor called, then id is equal to count and count plus plus. Okay, and here we are printing destructor called and count minus minus. Let us also print the id of the destructor, id of the object. id. Okay, and constructor called, here also let us print the id emdl. Okay, and IDs, let us print the ID after assigning an ID. So it will print the ID of the object created, and it will print the ID of the object which is destroyed. I think it is good. Okay. Then we need to define the static variable, we need to define the static variable count. So the name of the class is sample count. Okay, anything else we need here? I think it is good. Let us run it. Okay, main starts, constructor 0 called, constructor called for object 0, constructor called for object 1, then main terminates, then destructors are being called. Destructor is called for 0 and destructor is called for object 1. Okay, let us name these objects in a similar manner. This is S1 and this is S0. Okay, so what is happening here? The program execution begins at main. So main starts. Then S0 object is created. So constructor called ID0 is generated. Then we call function f. Inside f, S1 is created. So ID1 is generated. Then because this object is a static object, it will not be destroyed when the function ends. Okay, so it will remain in memory. So when we return, we execute the statement main terminates. Okay, and before the main actually terminates, it destroys the two objects. So which object will be destroyed first? The object with ID 0 will be destroyed first, and the static object will be destroyed at the last. Okay, so let us create another object S1 here and see what happens. S3, S2, okay. Okay, now see what happens. Main starts, ID0 constructor is called, ID1 constructor which is inside this function is called. Then we return here, main terminates, this statement is executed. Then we are creating another object S2, so ID2 is generated. And before the main actually terminates, the objects are destroyed. In which order the objects are destroyed? First, the normal non-static objects will be destroyed, and they will be destroyed in the reverse order of their creation. Okay, so first we created object 0, object with ID 0, so it is destroyed at the second place, and the object with ID 2, that is S2, was created later, so it is destroyed first. Okay, and the static object, it is destroyed at last. So this destructor called 1, so the S1, that is the object with ID 1, is destroyed at last. Okay, now let us create a global static object. Here in this function we created a static object, but the static object is local. Okay, so the static object is local to this function. Its scope is limited to this function only, although its lifetime is throughout the program. Okay, so how to create this global static object? We can define it anywhere. So static, then sample, and let's name it as 4. Okay, now let's try to run this. So you can see that constructor is called even before the main starts. What is the reason behind this? The reason is that any global variables, they are created even before the main starts. So this variable is also a global variable because we have defined it outside the class or outside the function. So this will be created, and then we have defined this global object. So this will also be created before the main starts. So S4 has got the ID 0. Then we go to main starts, then S0 has got ID 1, then we call F, and S1 has got ID 2, then we return, main terminates, then S2 has got ID 3, and then the destructors are being called in which order? The reverse order of their creation. So we created the object with ID 3 at last, so 3 is destroyed first and then 1 is destroyed. So these were the non-static objects which were destroyed, and then we are destroying the static objects. So first the static object which was local, inside this function this is destroyed, and then the global object S4, which is also static, is destroyed at last. So this is the order of execution of constructors and destructors using static objects. And these are the references for this chapter on the static keyword. Thank you.